Now that we know about truth table, we can use these truth tables to verify if two logical formula are equivalent or not. So by logical equivalence of two logical formula, so we had seen that we can represent any English sentence into a well-formed formula, which we also call logical formula. And if we have two logical formula, P and Q, and these in turn may be formed by multiple simple propositions like P1, P2, P3 and combined using some logical connectors like or, and, implies and so on. Similarly, this can also be a composition of multiple simple propositions. So by logic, they will be logically equivalent if for all the possible conditions. So every proposition can take two truth values, either true or false. And we can list down what are the different possibilities which we called as truth table. So for all those possibilities, if the value here, let's say it's A, so A is either 0 or 1, then for the same condition, Q is also A, or if it's 1, then Q is also 1, and if P is 0, then Q is also 0 for all the possible combinations of P1, P2, P3, and similarly here Q1, Q2, Q3. Then we will say that these two logical formula are equivalent. Now let's see some examples. So we are asked, are these two formulas same or not, equivalent or not? So in one case we have P and Q, and another case we have not P or not Q. So since it has just two propositions, there are four possibilities because P can take two values and Q can take two values. So I have listed down all the possibilities. So for 0, 0, this will be 0. This is AND, so it will be true only for 1 and 1, rest other 0. And so this is our first formula. Now we need to calculate this. So for this we will need not P and not Q. So first calculate not P, which will be the negative of this P value. So when P is 0, it will be 1, 1, 0, 0. Similarly, Q will be negative of, this will be negative of Q. So it will be 1, 0, 0, 1. Now we have to take OR of these twos. So if any one of them is 1 or both are 1, then it will be 1. So it's 1, 1, 0, 1. Now we have to compare, this is our second formula. So we have to compare the truth values of first formula and second formula. So here we see that it's 0, here it's 1, here it's 0, it's 1. So they are not equal for all conditions. In fact, they are not equal for even single condition. They are just opposite of each other. So if the formula would have been like negative of this, we would have said that they're equivalent. But here that is not the case. So we will see that the answer is no. If these two are not same, exactly same, then they are not equivalent. Now let's take another example. So here we have this not in front of this. So first calculate this. It will be 0, 0, 1, 0. Not of this will be 1, 1, 0, 1. So this is our first formula. Now not of P is 1, 1, 0, 0. Similarly for Q, 1, 0, 0, 1. And we will take OR of these two. So it will be 1, 1, because one of them is 1. Here both are 0. So it's 0. And here 1 is 1. So it's 1. Now this is second formula. And now we have to compare these two. So we see that for this condition, both are 1. Here both are 1. Here both are 0. And in the fourth and last condition also, they are same. So we will say that, yes, these logical formulas are equivalent. Now let's see some more applications of that. So we have to prove that P or not P is always true. and we call such conditions as tautology. So here there is just one proposition, and this P can in turn be a compound proposition, but in the end either simple or compound proposition will have only two possible truth values, 0 or 1. So for P it can take either 0 or 1, and for negative P it will be opposite of that, and we have to take OR of these two. That means if any one of them is 1, then it will be 1. So here it's 1, it's 1. So we see that it's always true because there is no 0 possible here. The truth table says that it's always 1, no matter what is the value of P. So now we have another example. Here instead of OR we have AND. And it's mistake here. It should be always false. And this condition we call contradiction. So we see that this AND is 1 when both are 1. So here we see that it's 0. So it will be 0. Similarly, here not P is 0. So it will be 0. So here it's always false. So this was one of the ways of proving equivalence of two logical formula. There are other ways like inference, deriving inference out of logic. And the third way is to compress the big logical formula. We can shorten them, we can simplify them, and using that we can prove different logical equivalences. So thanks for watching. See you in the next video.